So when we talk about Linux, the first thing that we should know all is that in Linux, everything is a file. And when I say everything is a file, it essentially means that my hard disk, for example, is a file. My mouse is a file. My keyboard is a file. Monitor is a file. And so as other things as well. So when I say it is a file, it essentially means that I can look at the configuration of that device or of that particular file on my operating system. Now in Windows, if you really look at, these are essentially configured items in one repository, and that repository is a registry. Whereas in Linux, the configuration is resident in a file and in a file type structure. So you can literally go to a particular file and look at the configuration, let's say, of a hard disk. You can look at what kind of file that is, etc. And it does not have, so Linux, any flavor of Unix for that matter, does not have a concept of a extension binding. So which essentially again means is that in Windows, we have an extension association. So a .doc file or a .docx file will open up with Microsoft Word. A .pptx file will open up with a PowerPoint. .exe will run as an executable and so on. So we have that association of the extension with the purpose of that file or the program which is going to execute that file. In Unix, we do not have those extensions. So even a file without any extension can be an executable file, or a file which is without having any extension can be a document file as well. So we will look at all these things as well, and why we need that information or that understanding from a security standpoint, because when we look at OS in detail, or when we do a configuration review, let's say, of any operating system, and Unix or Linux in this particular case, when we do these configuration reviews, it is very essential to understand what we are looking at. So I can share one example. When I was doing an audit for uh, a uh, payment company. So this company was into a software development, and they used to develop a payment gateways. So I was doing an audit for them, and during the audit, I ran a normal command to look at where all the card data could be in a particular directory, and I could figure out that there was one out file, which is the file name was nohub.out. So that file was there on the Unix system, having a dump of all the clear text card numbers, CVV numbers, the cardholder name, expiration date, and whatnot. And after inquiring with the client, we got to know that they have enabled a debug on one of the application, because of which the application is dumping all that detail into a nohub.out file. Now, if I really don't know what a nohub.out file is, I would not have been able to decipher or understand that this file exists on Unix. Sorry. So I would not have understood that it is there, and that's where it is important for us to be aware of how the Unix or any particular operating system works, so that we can make use of that information. Now, in Unix, we have two type of paths. One is an absolute path and one is a relative path. In Windows, everything starts with the C drive, D drive, and then the complete paths from there. Whereas in Unix, everything starts with a forward slash. So if I share my screen, uh, let me share my entire cell. Yeah, so you can see a black and white screen right now.
Yes.
Yes, sir.
That's a remote session that I have taken off my CentOS operating system. Uh, and I have logged in with a user U1. So if you look at the structure of this, it says U1 as the username, U1 as the username, at the rate the host where I am logged in. So it is a local host, and it can be a remote host or an IP address as well. And then this is the current working directory where I am. So this tilde sign means my home directory. So if I run a command pwd, I will get to see my home directory, which is home u1 in this particular case. And this dollar sign at the end of the command prompt denotes that I am a normal user. I am not a super user or an administrator of a system. If I change myself to an administrator, I will see that this dollar sign has changed to a hash symbol here, which means now I am a administrator of this machine and I can run certain administrative commands as well. Okay. Now, coming to an absolute path or the relative path. So if I do pwd, I see that the path starts from a slash in this particular case. So hence uh, it is a absolute path. Now, if I say ls this, the denotation starts with a double dot and it goes. So this double dot means a one directory back. So what I'm doing is I am listing ls, I am listing the content of one directory back, which is the home directory. So I see that I have got a U1. Let me just make this font a little big. Yeah, is it better now?
Yes, sir.
Okay. So if I do a one directory back, I see that my user is user one. So that's a content of this home folder. Now, similarly, if I go one directory back up again, I see different folders, which is the same as the content of a slash. Now, consider this root as a My Computer in Microsoft Windows. So you have a Windows, uh, which wherein you click on an icon of a My Computer and you see C drive, D drive, E drive, etc. Here you do not have that concept of My Computer. Rather, you have this slash, which is the starting of everything. So you have different folders down here, which is like boot, dev, etc., home, etc., etc. Now, these folders has certain purposes, right? And these purposes are nothing but what we have here. So these purposes are nothing but what we have listed down here. So we have bin directory, which is equivalent to a binary, which stands for binary, and it has all the user commands that a normal user with a dollar symbol can execute. Similarly, we have dev directory, which is a device directory, and that is the folder which contains all my device files. So for example, a mouse file, a hard disk file, a monitor file, a keyboard file. So all these files will be stored under a dev directory. The etc directory contains the configuration file of the Unix environment. So any configuration that we have to do for the running services or for a password configuration or for a user configuration, so those configurations happen within a etc directory. Then we have a home directory. Home directory is where when we create any user to the Unix system, all these users gets created under a home directory. So it's similar to what we have in a C drive users directory on Microsoft Windows. So we have C/users. Here we have /home. for those environments or for those home directories of the users. Then we have a lib directory, which relates to a shared libraries that we have on this machine. And in Windows, we have .dlls as the dynamic linking libraries. Here we have a lib folder where all the shared libraries are dumped or are stored. Then we have mnt or /media directory where we have the mount point. So for example, we can create so let's say if we have to mount a remote file system to our Unix file system, like a shared drive that we do in Microsoft Windows. So we basically map a drive to a particular drive letter. So here in MNT, we can create different mount points, and those mount points can be used to mount a particular remote share. And for example, we are inserting a CD-ROM into the system or a USB into the system. That's where we can have those mount points getting mounted under a media or the MNT folder in Unix. Then we have a root directory, which resonates to a home directory of a super user or a root user or an administrator. So again, this is something to do with Microsoft Windows where we have the users administrator as a folder. Here we have a separate folder, which is a /root. And this root user is the super user of the Linux or a Unix environment. Then we have sbin directory, which has all the commands from a super user perspective. So all the command that administrator can run gets stored within a sbin directory. A TMP directory is there, which is to store a temporary files or a temporary storages. So that's a TMP folder. In Windows, we have, if you go to a run and you do %temp %, you get a temporary file or a folder there. Here it is a /TMP directory. Then we have a USR, which stands for Unix Shared Resources. So this USR directory contain all the binaries for the server services. So for example, Telnet, FTP, DHCP, DNS, or a bind or Apache. So all these binaries, or so when I say binary, it's basically an executable. So all these services executable are stored sometimes in the USR directory as well. And why USR? Because it is a shared space between a user and a super user. Then we have a var directory, which contains a variable data. So for example, a data like logs, a data like emails. So all that gets stored under a var directory, which is a variable in nature. Then we have a proc directory where all the running process related information stores. Now, when this is something which is unique to Unix and unlike Windows, so here you can actually, like I said, everything in Linux or Unix is a file. So even the memory content that we have, that is also getting stored in a file format itself. And if we really look at this file format, what we see, so if we go to a proc directory, here we see a lot of folders with the numbers. So we see a lot of folders with the numbers. These numbers are nothing but the running processes in the memory. So if I do a top command, I see that these are the PIDs or the process IDs. Now, let's say I want to look at a particular process and see what kind of information is there. So let's say I choose this particular process. Uh, Anything we can take. So let's say this process number 18. So what I will do is I will go to a folder of number 18 because that's what we are interested in looking at. And we do a normal ls command. These, this, or rather, these are the information which is a memory information for this particular process. Now, if I really need to look at what this process is all about and what command this process has started, so I can look at scat cmd line. And this, since this is a system process, I don't see this as a cmd related process. Uh, but at the same time, I can, let's say, look at uh, mount info, it will not have any mounts as well though. Let's look at a IO. I will have to run this with the permission. So if I look at the IO, I see that no disk activity is being done with this 18 number process. Let's go to some interesting one, and let's say 2808, just a random process. And if we look at CMD line, so if I look at a CMD line, I see that this particular command has started this process 2808. And if I look at 2808, I get the same command here as well. So this command is for 2808, and if I look at the IO that this command is doing, I can see that these many bytes are read and written. These are the system read characters and the write characters, which is in the memory of the CPU itself, or the mem cache. So these, again, this is not in terms of the disk activity. The disk activity will come here. So no disk activity is being done by this process either. So when we look at these processes, why we need to understand this proc file system is because when we do a forensics, for example, for a Linux machine, or when we are writing a malware signatures, we need to be aware about the strings which we may find in these process directories. So with a malware, specific malware in place, we the way antivirus works, for example, they work on signatures typically. Now, from a signature perspective, it is a pattern which they identify in the ASCII character of a binary. Here, since we do not have a binary, we have a memory information wherein we can also look at the malware signatures or a specific ASCII character in the process memory itself. So that when we create our uh, anti-malware or a malware scanner or something of that sort, we can look into these files to see if there are any specific strings available in these running PIDs. And if it is, then we can mark that particular PID as a malware infected or a malware itself. So that is something that we can do with this information. If I look at, for example, uh, so let's say Mem Info. So it will give me a memory information. So it will give me the RAM which is there. It will give me the, so for example, Mem total is roughly about this much KB. So you can translate that to about 8 GB. How much is free? This much is a free memory. This much is a memory available after the system use, and all that stuff. So this is a Mem Info file. Similarly, if you look at the modules, it tells you about what are the different modules which are loaded. And modules are nothing but the libraries you can think about. So so these files we will look in detail as well, but these files are essentially the information about the Unix itself. So this proc is nothing but a process file system. So it will tell us about the memory, it will tell us about the CPU, it will tell us about the running processes, etc. For example, a CPU info file can tell us about the course that we have, or what kind of a processor that we are running, what is the stepping or the CPU processing speed that we have. So all that information will be dumped here from a CPU info file. From our, I would say, from the virtual memory perspective, if I look at this K-core file, it says a regular file, no read permission, and if I dump this, if I dump this, Now you see my terminal is stuck. The reason for this is a physical memory file, the RAM content of the file, and I cannot dump that onto the terminal because it contains some non-ASCII characters as well, which can really affect my terminal. So it will not affect my operating system though, but it will affect my terminal, the session where I am working. But if you really look at, there are certain ASCII characters in here as well. So for example, if you really look at here, you see core R, VM Linux, boot image, some image name VM liners. That's my kernel. Then root, dev, mapper. So all these are the ASCII characters. Why these ASCII characters are needed for me is, again, when we from a forensics perspective, when we dump, we use a strings command to read this particular file. So for example, if I run a strings kcore, and I'll just make it a more, so I will get the readable strings out of it. So I will get the readable strings out of it. So for example, core, boot image, I got. Then OS release I got, and this rest of the information was any which ways coming earlier as well. Now, for this information to get captured, when we create our forensics, or when we run our cyber forensics onto Linux, the first step is to capture the non-volatile information as well, or a volatile information, sorry, as well. So first we capture the volatile information and then we move on to the non-volatile information. So considering that this is a RAM content, this stands to be a volatile information. So the first step that we do is capture the volatile information into an output file. So we can simply run this command and dump these strings into our output file by simply putting in a redirection counter. So for example, we can just redirect this to a file which is in the TMP output. Now, if I look at this file, so it is empty. So is strings equal. Okay. And this information is what I can put into my output file. So for example, you see these strings coming here. Now, since it's a RAM content, this information will keep on changing the time I will run this command. Okay.
So this is the opcode which is running. All these numbers are opcode and the.
Not the opcode. So typically what we see in the RAM is a running process. So for example, if I run a top command, these are my RAM content, the processes which are there in the RAM. So it keeps on changing because the priority of the process, or the process is sleeping and then coming into the effect. So the list is keep on changing. So for example, this list will keep on moving upside down, and the active processes will come at the top, and then the inactive processes or the sleeping processes will come. Now, these RAM contents, if you look at Windows, these are all in a binary state. So you can't read them with your any, I would say, editors like Notepad or a WordPad or Microsoft Word or stuff like that. So you need a software to open that RAM content and then look into what exactly was there. Same case in Linux as well. So you need a specialized software to open the entire content of a RAM. However, with this K core file, what you see is the strings or the ASCII characters, which are printable characters like A to Z and then 0 to 9. So these characters, which are available in whatever the process running in the memory, you get to see those printable characters in a straightaway fashion. So you don't have to really I would say wait for a software to open up. You can do a first level or a preliminary analysis on this K core, and then you can later on open this K core with the specialized software as well.
And this is the memory for all the processes.
All the processes,
Okay.
yes. For respective process, you have those folders or those IDs of the folders where you can navigate. So these folders are respective to the respective processes, and whatever is outside the process is a system wide.
Can we also dump this into a memory file or a copy of that, like how we do in Windows?
So you cannot copy this file because this is this is a RAM content. So when you do a forensics, you use a software like FTK Imager and stuff to copy these files into a secure disk. You
Okay,
can
yeah.
Yeah, but you can do that, but then you need a external device to be attached to the system where you can save this particular file.
Is that like a kind of OEM or open source?
Open source, open source, open source. So FTK Imager is open source. So anything you want to image, so software to capture the image is open source, or I would not say open source, but is open to use commercially as well. But then software to analyze the RAM content, you need a license for that.
Okay. One more question I have, sir. Maybe it is too early to ask. We are these days we are actually talking about runtime security for all the data that is loaded in the memory. So whenever we're talking about security for the process which is loaded in the RAM, are we creating the security tools? Are we creating a wrapper around all this particular process to monitor how the technology works? Maybe if we are discussing this later, that's fine.
No, I didn't get the question, please.
So when these days we are talking about operating system runtime security, right? Those
Hmm.
processes that is actually loaded within the operating system, and we are continuously monitoring how they are actually performed and if there is a leak or something.
Hmm.
So is this again related to monitoring the process or monitoring the specific applications that are loaded as
No, no. So from a process security standpoint, we have a concept of SE Linux. Okay.
okay?
Wherein you can really limit the resource access. You can put the limits or the thresholds on the memory, on the disk, what activity can be done, what activity cannot be done, all that stuff you can put the restrictions upon. Whereas in what we are looking here is from a basic understanding that in Linux, we have everything as a folder or a file, and under these folders of the processes, we have certain information which is related to a process. So a memory consumption or a disk activity or a CPU utilization, all that which is related to a particular process, you can look inside a directory of that PID or a process ID. And anything which is outside that process ID, you need to be aware that these are a system-wide uh, effect or a system-wide real-time information. Okay,
Yeah.
so when you create, let's say tomorrow, if you create a scanner for a malware, you can go recursively in these folders to look at a specific string, whether that scanner has identified a string in the running processes or not. So when you do, for example, your threat intelligence session and you get introduced to a Yara rule, so you can create a Yara rule to look into these running processes recursively and iteratively so that you get to know whether those signatures are available in these running processes or not. What has happened in a Cosmos Bank, for example, they did not had any log activity of the ransomware, or not the ransomware, but a malware on the disk. So the malware was there in the memory, and malware was approving all the transactions which were coming from an ATM without sending those transactions to the ACS system for authentication and authorization. So the
Okay.
moment ATM transaction comes into the server, no disk activity used to happen from a malware perspective because it is loaded into the memory. The module will look at the transaction and approve that transaction by sending up a success code back to the ATM. So the attackers took out a 90 crore rupee, roughly about 90 crore rupee from ATMs in India. And this malware, since it was in the memory, if you run a antivirus scanner, it will not identify on Windows operating system, for example, because the antivirus or anti-malware is largely working on the files which are there on the disk.
Yeah.
Uh,
Yeah.
Here, in this case, because it's a content stored on the disk for the folder, you have that extended benefit wherein you can look into the content of these files as well for a specific signatures.
Okay.
Okay.
Sure.
So how we take the dump here in Linux environment? Like we actually, when we do the Windows RAM forensics, we usually use the third party to like mem dump, and then we,
You can
once we
use
have, yeah.
memdump, correct. So you can use memdump in Windows, or you can use FTK imager in Windows. Here also you can use FTK imager. There is a command line for FTK which is available. So you can use that same command line to dump the content here as well.
Okay, so that won't be happening within, right? We need a third party tool to dump the memory as well in Linux.
Yes.
Okay.
Okay.
Yes, sir.
Right. Then we have already taken a look at the directory structure, so we will skip this. Then we will understand the run levels that we have. So in Unix, we have 6 run levels. So any Unix you talk about, you have 6 run levels, though the definition of those run levels may differ depending upon the Unix implementation. For example, in Solaris, the implementation can be different. In Linux, the implementation will be different. Now, these 6 run levels has some specific purpose. In Windows as well, if you see, you have some kind of run levels wherein you have a GUI, which is the by default run level in Windows. You directly land up with the login screen and you log in there. So that's one run level that you have in Windows. The other run level you have in Windows is a safe mode. And in safe mode as well, you have multiple options: login with networking, login without networking. So those are again two different run levels that we have in Windows. Then when we click a restart button in Windows, we enter into another run level. And when we power on a system, we are starting up a run level itself. So though they are not 6 in Windows, but they are still 4 to 5 run levels in Windows, depending upon the use that we may have. Here in Linux, it is very well defined run level. Now with the newer operating system, these are called as the targets as well. So a run level 0 usually define a power off situation. So if on a Linux system, I do a power off, or if I say init 0, it will shut down my system. If I put init 6, it will restart my system. If I say init 1, it will take me to a single user edit mode, and that too on the CLI. So I will be on a single user CLI mode. Now, from a run level 2 perspective, we have got a non-networking CLI mode. So that's the run level 2. And run level 3 is similar to run level 2, wherein it is a networking enabled CLI mode with multi-user. Now, the difference in run level 2 and 3, if you really see, is all about the networking or the services which will be running from a networking standpoint. So you have, for example, if you're running Apache as a web server, or if you're running a NFS as a network file service, or Samba from a sharing perspective, then those services will not be running in a run level 2. But rather, if you have to run that, you will have to upgrade your run level to run level 3. Run level 4 is a reserved run level wherein you can create your customized scripts and you can use that particular space to create your own custom run level. And then you have run level 5, which again is a default nowadays for Linux, wherein you are directly taken to a GUI screen and it's a multi-user networking GUI mode. So that's a run level 5. And then you have run level 6 to depict a reboot situation. Now, if we have to really look at this from a demonstration purpose, for example, so I have got this machine. If I log in here, and if I go here, and if I say init 3, init 3 is a multi-user mode without GUI, but all the rest of the networking services will be intact. So nothing will change, only the GUI mode will go away. So if I say init 3 and I enter my password, I will be downgrading my run level to run level 3. Right now, I was in run level 5. And if you see now, I am at a console, which is a run level 3. So I will, let's say I log in here. And if I check my run level, it says 5, but so that's my default run level. But right now, I am at a run level 3. Now, if I say init 5, I will be upgrading to myself to the run level 5 back again, which is a GUI mode.
Here there is no reboot like Windows when you're changing the run level side, other than if you're going for a
So reboot, I can simply say, no, so reboot will not happen because that's a real-time change that I am doing. So the way run level works, it's basically a combination of scripts. It's a cumulative scripts that runs at the back end. So when your system starts, it starts with run level 1, then automatically it increments to run level 2, then run level 3, then 4, then 5. Now, in the process of doing these 1, 2, 3, 4, 5, what it does is it starts all the services at run level 1. Then it starts the services run level 2. Then it starts the services at run level 3, at 4, and then finally at 5. So by the time you reach up to a stage 5 or a run level 5, you have all the services up and running from 1 to 4 or 1 to 5. Now, once you want to degrade yourself from 5 to 3, you are basically stopping certain services, right? So here, like for example, this GUI is a GDM service, is a graphical display manager service, which runs. So when you transition from 3 to 5 or 5 to 3, it's a configuration change or the killing or the starting of a process from a GDM perspective. So if I log in here again, this is what my GUI interface looks like. I think I'm entering the wrong password. I think some problem with the password. I will reset that. But that's how typically you transition from a run level 3 to run level 5 and so on. Now, if you really look at my session, it is not impacted. Reason being my network service is common between a run level 3 and a run level 5 both. So I have a common service, which is a network service running on both the run levels, and hence my session was not disconnected. If I have to restart my system, I can simply put a reboot command, or I can simply say init 6. Both are equivalent. So I can use init 6 or I can use a reboot command to restart my system. And if I have to halt my system, I can simply say init 0, and that will put my system to a halt, which is a power off situation.
Okay.
Okay. So yeah. So these are the 6 run levels that we have. Run level 0 is a power off. Run level 1 is a single user CLI mode. Level 2 is a multi-user non-networking CLI mode. Level 3 is a multi-user networking mode, then reserved, and then multi-user networking GUI mode. And then last one is a reboot situation. Now, in the current operating system or the modern operating systems, we do not call them as run levels. We call them as the targets. Now, these targets or these run levels, so as to say, are predominantly similar in nature, but they are slightly different in a configuration perspective. So earlier, what we used to have is we used to have a file called init tab. So we used to have a file called init tab, and this file used to contain the configuration for all the run levels. Now here, if I really read, it says adding configuration here will have no effect on your system because this init tab is no longer used. Okay. And it says multi-user.target is analogous to run level 3, whereas graphical.target is analogous to run level 5. If I have to see what is my default run level, I can run this command to see what is my default run level is. And my default run level will be the graphical target or a run level 5, which is the current one. Okay. If I go to this folder, sorry. So if I go to this folder, I will have multiple services, sockets, targets, etc. written. So you have a target file, you have a service file, you have a socket file. So you have these files available. What I am interested in knowing my target file. So I can say ls star.target. So if I do star.target, these are my target files. Now, if I look at here, it says run level, blah, 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 um, uh, run levels, and then the dot target. My default run level is a graphical dot target, which is this particular file, right? So what I can do is, or let's say if I do my default dot target, which is this file, so it is a soft link to a graphical target. If I do a similar listing for this particular file, it is a power off target. If I do a listing for this file, it is at a rescue target, which is a run level 1. So essentially, if I do ls hyphen listing of run level star dot target, then these are the respective names of the target file. So run level 0, power off, Run level 1 is a rescue mode. Run level 2 is a multi-user. Run level 3 is again a multi-user, but in this case, it will be a network enabled. Then run level 4 is a multi-user, but this is a customizable one. Run level 5 is a graphical, and run level 6 is a reboot target. Okay, and these were the 6 run levels that we were talking about. Now, let's say if I look at a rescue target. So if I cat this file, which is dumping the content of this file, I simply see a description, which is a rescue mode. If I have to look at the documentation, I can look at man 7 systemd.special, what it requires. So where this service depends upon. So this rescue.target file requires a system init.target to be executed and rescue.service to be executed. So if I have to run rescue.target, these two services will automatically be starting. What is the sequence of running these services is coming in the after. So system init.target first and then the rescue.service. Now let's look at the first one or the second one. So if I dump the content of this, what it says requires basic.target, conflict, rescue.service and rescue.target. So it starts with a basic.target, then rescue.service, and then rescue.target, which means my rescue.target file, which is in this case, will be executing after starting the rescue.service. So if you remember, I said it's a cumulative start of the service. So if I look at here, which is my multi-user.target, I am starting multi-user with a dependency on rescue.target. And rescue.target will have sysinit.target and rescue.service running automatically. Okay. Now, if I look at the third service, which is multi-user.target, if I look at multi-user.target, what it requires is same basic.target, basic.target, rescue.service, and rescue.target. Now, this third service, if you really look at multi-user.target, it is common across the three. Right? It is common across the three. So if you have to change anything, for example, if you have to change a run level 4, which is a customizable or a reserved space, you can write your own target file here. You can write your own service file, and then you can configure that to run the run level 4. Now, if I look at this particular file, rescue.service, if I look at this rescue.service file, it also talks about starting a particular service in a particular fashion. So sysinit.target needs to start first, and then this particular service, plymouth.start.service, needs to start. From a service configuration standpoint, these are the configuration parameters for this particular service. Okay, so you can create your own service file. You can create your own target file and link that target file to a run level 4 or 2 or 3, wherever you want to link it to. And you can set your default um, run level to boot into that particular mode. Okay. All right. Okay. Then we have a file systems. So in file system, typically what we have is we have got different file system types. So we have got a VFAT, we have got NTFS, we have got XFS, we have ext3, ext4, and whatnot. So these are different file systems. available in the Linux environment. In Windows, we typically have a NTFS and a FAT32. In earlier days, we used to have a FAT16, but now it's predominantly FAT32 and NTFS which are used. And all the file systems have different capabilities. So for example, ext3 and ext4, the difference between the two is a journaling. And with journaling, what used to happen in ext3 is, for example, your system is running and your system crashes all of a sudden. Then whatever file handles that were opened. So for example, any notepad that you're working upon or any configuration file that you're working upon, if the system crashes at that time, the changes will be lost in ext3 file system. And when you try to restart the system, because it has some unlinked data, the system used to panic and system used to take a longer time for administrators to recover. Then ext4 came to rescue, wherein they created a folder called lost plus found, and any open handle of a file used to go and save there automatically during the crash. So anytime you open a file, a lost plus found folder will be there, a hidden folder, and a copy of that file will be retained there. So if a system crash situation happen, you can recover your work from a lost plus found folder itself. And from a restoration of a file system perspective, since ext4 has a lost plus found folder, any data which is considered to be a data loss can be found within a loss plus found by the system, and the system used to rebuild its data automatically using that folder structure. So that is where ext4 came into existence. Similarly, we have Razor FS, we have ZFS, and whatnot today. And all these file systems, either provide a security or provide a performance. So either of the factor they provide, and that's the different file systems that we have in Linux. Now, from a file system perspective, again, there are three common commands that we need to be aware about. One is a FSCK, which is to do a file system checks. So when our system starts, there is a file called Atc Fs Tab. So we can edit this file to make sure every time the system starts, the file system check is carried out. So that we can do. Then we have, or manually we can also invoke FSCK to carry out the file system checks. The second command that we have is a mount command. Now, this mount command is something which is very common and is also used commonly across different purposes on the OS. So this mount command typically has a format wherein you have to mandatory provide two parameters at least, and those two parameters are the what to mount and where to mount. So these are the mandatory parameters that you have to provide. Rest all parameters are configurable. So for instance, if you want to mount a specific file type or a file system type, that you can specify with the -t command. If you have to specify certain options, you can specify those options in a comma separated list with the -o option on the mount command. And if you want to mount it as a read only, you can supply that as a option as well. And then what to mount and where to mount. Now, what to mount is a device file and where to mount is a mount point. So we will look at a output of a df-h, for example, to see what to mount and where to mount is there. So if I run a command df-h, it gives me a information about my disk from a perspective of what is mounted. Now, this is what to mount, and this is where to mount. This is what to mount. This is where to mount. This is what to mount and where to mount, and this is what to mount and where to mount. Now, the mount points can be different. So you can have different mount points. the what to mount are usually the block devices or the block special devices, such as your CD-ROM device, for example, your hard disk device, such as your USB device. So those are the device files which usually come under the what to mount. Where to mount is your freedom, wherever you mount to do, wherever you want to do. And these mount points, MNT and media, are something which are indicative. You need not necessarily be mounting everything under the MNT or media folder. You can have a different folder where you can mount these uh, the device files, right? So that's the mount command that we have. Similarly, we have a umount, which stands for an unmount of the disk. So you simply give unmount and the mount point where you have mounted it, and it will unmount the disk or the device file for you. The other command is a fdisk, which is to do with listing of the disk structure, and then working with the partitioning of the table, deleting a partition, creating a partition. So all that things you can do with the fdisk command. Now, fdisk usually in from a cyber perspective, we don't use fdisk that enough from a forensic standpoint or from a cybersecurity standpoint. The reason is it is only for an administrator to manipulate or manage the partitions. But we still sometimes use it to list down what all partitions are available on the machine. And it can be a bootable partition, it can be a non-bootable partition as well. So if we run our command fdisk-l, we get to see what is there. So for example, if we run fdisk-l, okay, if we put this command, then we get to see what are the different disks which are attached. So for example, here I see that I have SDA1, which is a boot partition. And this is the starting sector and the ending sector. Total sector size is this. What is the size of this particular partition and what type of partition it is. And then we have a device 2, which is a SDA2, and again the starting and the ending sector of it. Now, what we see here is a SDA1 and a SDA2. SDA1 is nothing but my device file for a hard disk. And it can be SDA, it can be HDA. So SATA, typically a SATA disk starts with SDA. Any IDE device or a IDE disk, for example, the earlier era disk that we would have, that will start with the H letter. So HDA1, HDA2, and so on. The other, uh, so information that we see here, for example, is it is a 12 GB size disk. So SDA is a 12 GB size disk. These many bytes and sectors are available. The one sector is a 512 byte in nature. That's a configuration on this particular machine. So if I have a number of sectors, I can multiply that number of sector with 512 to get this number of bytes. And then from these bytes, I can create a megabyte and I can create a gigabyte or a terabyte as well. So that's the information which is provided by the fdisk by doing a fdisk-l command. If we simply put fdisk, it takes us to a menu. So let's say dev SDA, it takes us to a menu where we can create or delete a partition. So for example, here what we see is for the DOS or a MBR partition, I can toggle a bootable flag. If you see here, where is that? If you see here, it's a bootable flag on for SDA1. So if I have to make SDA2 bootable, I can toggle that flag on and off for a particular slice or a particular disk partition here, so that I can do by using the fdisk and by going into a particular disk file. So fdisk dev SDA will take me to this menu where I can do the administration task for that particular partition or that for particular disk drive. I can delete a partition and I can print the same partition table information again by putting in a p command. So I will get that same information back again. So all these things you can do with the fdisk command. From a forensics or from a cyber standpoint, it is typically a fdisk-l command that we use to see what all devices are attached to the particular machine. So that is the information that we get from a fdisk command from a cyber standpoint. Now, these are some of the options that we have in a mount. So for example, we have a async option wherein all my processes of a disk IO will happen in a asynchronous manner, which means it is not going to be a synchronized disk operation. It is going to be a asynchronized disk operation. Asynchronized disk operation usually increases the speed of the processing. However, it has a demerit on the life of a disk. That is one. And secondly, it puts load on the CPU as well, because there are multiple processes which are going to run in the memory. So from that perspective, a asynchronous process is not a preferred way. Usually the file buffers that we use or that we want to use them in a synchronized manner, so that whenever a line is written in a buffer, immediately that buffer line goes to a file and written down there. So we prefer to do a sync operation rather than the async operation at a partition level. The other area of consideration is a no exec mode. Now, exec mode allows a executable file to be executed from that particular partition. Whereas if we want to limit the restriction on the executable file, that nobody should be able to execute that file irrespective of the user role, then we can simply put this particular flag or option as no exec. The third option that is commonly used is a SUID. We are going to see what is SUID, SGID, and sticky bits all about. But SUID allow that functionality to happen. If you say no SUID, that functionality will not be available. Then we have a RO, which is a read-only mount that is used again largely when we are doing the malware analysis. So when we do the malware analysis, we need to be aware about it so that uh, we can mount the file system, scan the file system without deleting any file. Usually what we see when an antivirus scans a file and it identifies a malware, it immediately either deletes that file or put that file into a quarantine. We don't need that behavior to happen. What we want is rather antivirus should report us that these files are impacted, but they should not be able to delete or move that file. So that's where we put the RO option when we do the forensics. Okay. All right. So meanwhile, have you got the chance to your lab machines as well?
Yes, yes.
Perfect. Then the next file that we have is the Etc Fs Tab. Now this Etc Fs Tab or the file system table file is all about the the boot time configuration of the file system. So what happened when we start our system or start our Linux operating system, it automatically mounts these files or these file systems onto the Linux environment. Now, what order it has to mount and with what configuration it has to mount, that goes into the Etc Fs Tab file. So the structure of this Etc Fs Tab file is into a 6 stages or a 6-factor file. So the first is what to mount, then where to mount, what file system it is, then what are the mount options that we have. So we have seen these it has and what kind of file system it has and with what options we need to mount it. Then we have a dump or a crash dump, whether we want to create a crash dump of this particular partition. If a crash dump situation happens, yes or no. So 0 for no, 1 for yes. And then whether we want to run the FSCK as well onto this or not. So, and here in the FSCK, we can give 0, 1, 2, 0 for no, 1 for yes, and 2 for halt if there are errors. Okay, so you can give 0, 1, and 2 here for the FSCK option here. Okay, to run FSCK. So, for example, if I look at my partition, I see SDA1, let's say boot, right? So I can run fsck/boot. Okay. So since it is mounted, I will not run here, rather I will run on the device file itself. So I will run it on the device file and it has not reported any issue. Now, if I run the same on the mounted file system, it will unmount first, run the FSCK and then mount back again. Okay, so I can run this FSCK on the device files, and once I run that device file FSCK, I get to know whether there are any errors on that file or not. Clear?
Yeah.
Okay.
And is there a possibility to schedule for FSCK during the boot, like how we do in Windows?
Is there a possibility for FSCK to be?
Scheduled for checking the file system during the boot.
Yes. So if you have to check the file system during the boot, you can basically go to this file. So first become a super user. And then you can go to this file line entry and this last 0, you change this to 1.
Okay, that's a step.
Yeah. And then it'll, so on the next reboot, it will automatically check the file system with the FSCK.
Okay.
Okay.
So the FSCK have very less entries, but if we say df -h, it has a lot of entries. There's like a lot of mounts are there.
Yes.
Yeah, there's so many temp mount.
Yes.
And SD1.
So for example, this is something which is mounted by me. Okay. After the system has been started. Okay.
But even without this also, there's so many others.
Yes. So, and the reason for that is, for example, boot is something which you want at a boot time to happen automatically. Slash is something which you want to mount during the boot time because that's where your targets, your dot services are all stored. So until or unless you have a slash root, you will not be able to mount anything. Slash boot, until or unless you have, you will not be boot into the kernel. So you will not find a path to that particular file. Now the rest one, for example, slash dev. If you see, it starts with a slash and then comes a dev, which means this is something after the root has already mounted, and this can be mounted by any service as well. So when we run so for example, at a boot time, we mounted our partition. After that partition is mounted, we ran a service, and that service mounted another partition,
Okay.
right? But predominantly for an OS to start, for an OS to run, the entries which are needed mandatorily are these only. So if you look at what are these entries, these are, so swap space, for example, is my virtual memory. Slash boot is what my where my Linux kernel resides. Slash is the entire file system. So I mounted entire file system. Then I mounted slash boot so that my Linux kernel can boot into. And then finally I mounted my virtual memory itself. Okay. And once I do a slash boot, the kernel will start certain services, and those services will mount the rest of the file system as required by them. Okay.
Also, the order mentioned in the Fs tab and the df output
It will be
that
different.
it will be different. So
Yeah.
okay, because the root one is not listed in the Fs tab in the beginning, right? I mean df is in the beginning, but Fs
Yeah.
tab, that's the first entry.
Correct. It is here. Yes.
So how it decides internally what has to be brought up first?
No. So df-h is nothing to do with the order. It's just a dumping of my disk information.
Mhm.
Okay. So it doesn't. Even if this slash comes at the last, it doesn't really matter because this is just a informative tool. It doesn't change anything on the disk.
Okay, but the booting order will be based on the Fs tab entry.
Fs tab entry. Yes.
Okay, fine. Thanks.
Okay.
That means if I want to have some custom mount, it need to be at the end of it. You
Enter.
cannot add it. Okay.
No,
Because
because until or unless slash is mounted, you will not be able to mount anything.
right, right. Okay, that is right.
Yeah. Clear?
Yes, yes, it is clear. So this kind of Fs tab, it does show up in containers also, right? I mean, without Fs tab or
Yes. So
yeah,
in containers as well, the way containers work or the way containers are by nature, if you really look at, the containers are nothing but a small environment which is needed for a particular process to run. And because it has its own memory limits, its own disk usage, its own IO, so it doesn't interfere with the rest of the operating system. That's how the containers are. So they are like a virtual, um, how do I say? It's like a VMware for a process rather than a VMware
that,
for the server, right?
yeah, right.
So that's how they are. And in doing so, they also need a file system interaction. They also need, for example, if they have to create a PID, they need a slash proc folder. To have a slash proc folder, they need to have a slash. And to have a slash or to behave like a process in a virtualized environment, they need to have all the bare minimum stuff that they need. So for example, Fs tab, your etc folder would be there with some configuration files, your proc folder will be there, your home environment will be there for that particular process account and stuff like that.
That is correct. Yes.
Yeah. All right. The next thing that we have is a Unix permissions. Now, from a Unix permission standpoint, if you really look at the way Unix permissions work is slightly different than our normal permissions in Windows works. So in Unix, we have two permission concept. One is a normal ACL or a file system ACL, and then there is another ACL which is a extended ACL. So we will take a look at both the ACLs, but at first, from a concept standpoint, uh, the way these ACLs work. So let me put a rough note here. So the way these ACLs work, we have user, we have group, and we have others. This is for a normal ACL. So what a user can do is a read, write, and execute. What a group um, uh, people in the same group can do, or a group members can do, is a read, write, X. And what our others can do? Others are somebody who are not part of that particular group, and they are not the user or the owner of that group as well. So when I say user, it's the owner permission. So owner, group, and others. So when we create a file, we usually see a file permission which is listed on the leftmost side of the screen. So this is what the permission that we really look at. So if we really see this, we see L, which denotes a link, a soft link. We look at a minus, which is a normal file, and then we also look at a D, which denotes a directory, right? So initial character is for the type of that particular file is. So we can have a dash, we can have a D, and we can have a link as well there. Then comes the three positions for the owner of that file. Then comes the three position for the group members of that file. And then comes the three positions for the other users of that file. If I really copy this particular stuff here and if I paste it here, so this is a regular file. So the owner of this file can read and write. It is not an executable file, so there is no X here. Then the group members of the same group where this owner belongs, they can only read the file, they cannot write anything to the file. And same thing for the other users who are neither the owner, neither into the same group. So they can also read a particular file. Now, the way these are set, for each permission, we have a depiction in a numerical format as well. So read, for example, stands for a numeric 4, W for numeric 2, and X for numeric 1. So if I have to say this particular permission, I can sum this up. So I can say 4 plus 2 plus 0 because it's dash. So the permission is 6. Then R minus minus, it's only read. So 4. Again R minus minus, so again 4. So the permission on this particular file where we have this permission is a 644. In a words, it is RWRR. In numerics, it is it is 644. Now, if I have to, so let's go to a temp folder and let's create a temporary directory. Okay, I don't have any file here. So let's say I create a file testing here. The permission that I get by default is 644. My user is root and the group is root only because I am a super user. Okay. Now, if I exit and go to this folder, I see a testing file and I can cat the content of this file without any error because the permission of R is written here. So let me change the permission of R for others to a blank. So what I can do is with the sudo, we will talk about the sudo command as well. So with the sudo, I can say change mod. Okay. 6 for read write, 4 for read giving to the group, and 0 for nobody else can read this file. And I can say testing. Now, if I look at the permission, it is RWR minus 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 minus. Now, if I try to do a cat testing here now, I get a permission denied error here. Whereas in the earlier situation, when we did the same thing with the normal user, we were not getting any error. But here, when we do the cat testing, we get the permission denied because we do not have a permission here. Okay. Other way of giving or revoking a permission is, so I can say plus, so other plus R on testing. Now, if I look at, I see this again, and now I will be able to do the cat as well. If I want to give a execute permission, so I can give a execute permission to a user by saying u plus x, and I see that x has been given here. This change of a color doesn't happen in Linux or any of the Unix. It is just a feature of putty. So this tool that I'm using to remote connect to the machine. It is its feature that it shows a green color. If you normally see, it will be a normal this color itself, a black and white. That's it. Okay. So we have got X here and we have got a testing here. Now, let's say if I create a directory under Reva as batch 6. And I go to batch 6 and I create temp1.file. So I created 3 files, and what I'll do is I will put some content into these files. So I have got the content into these 3 files. Now, if you look at a directory, you see it is a execute permission given for all. If I revoke, so let's say read, I will retain for a normal user, but I will revoke a X permission for a batch 6 folder. So what I can do is other minus X, or I can say 6 or either of it is okay. So I can say other minus X and then batch 06. Now if I try to go under a batch 06, which is a directory. Oh, I have taken a read permission. Plus R minus X. Yeah. Now, if I try to go under a batch 6, it says permission denied, right? So for a directory, we need to have a executable bit set for us to enter into that directory. If we are unable to enter into a directory, it means either the permission for execute is not given to us or it is not set at all. So that's where we can just look at whether that X bit is set here for this batch 06 folder or not. Clear?
Yeah.
Now, yeah.
Sir, I have a question. So,
Yeah.
since you have custom set the permission to the primary directory under this partition batch 06. So, whatever the directories you create underneath batch 06, will it inherit or it will
No,
take default permission?
no, and I was just coming to that only. That
Sure.
for inheritance, for any permission to be recursively changed, I would say, what you need to do is you can, with the ch mod only, you can give a capital R as an option and then say others, I don't want a read and a write permission on the batch 06 folder. Now, if you really look at the permission for read, writes, read and execute goes from here for batch 06. If I go under a batch 06, I see the same permissions have been gone for the users as well. So I don't see those permissions on the temp. Now, if I create another file, which is, let's say, temp4.file, I will see that my default permissions are back here for the temp4. And why this is happening? Because of a umask. That umask, we will look at this file any which ways in some time. So that umask is defined here, 644 will be the umask. Grep. Yeah. So you see a umask here, which is 022. So it's basically an offset value. So just deduct this from 666 and you will get the default permission here. So if you look at 644, it is like this. Okay. So you deduct 6, 6 and 6 and mask it with 022, you get 644. And that's what the permission, default permission, which gets set on the file.
Got it.
Okay.
Yep.
All right. So let's look at here. So it is standard for all Unixes. So be it a Solaris, be it a AIX, be it HP Unix, be it Linux, any flavor of Linux, these permissions will behave in a similar fashion. The mask can be different and mask can be changed as well. So those masks can be changed and we can have those new permissions with the newer mask as well. Every file is owned by a user and has an associated group as well. So what we see here is a user and a group, similar to what we have seen, a user and a group we had for each of our files. So that's there. Then permissions often displayed in a compact 10 character notation that also we have seen. To see the permission, use the ls-l command. So once we run that, we see these commands like we see these permissions like this. And then this is just a denotion of what we have seen. So RWRR is read and write for owner, read only for everyone else. This is read write for owner, read for group, and forbidden to others. This is read write execute for owner and forbidden to everyone else. And then this is read for everyone, and this is read write and execute for everyone. Any doubts here?
That's clear.
Okay. From a directory standpoint, the permission bits are interpreted differently for directory. Read allows listing names of the files in the directory, but not their properties like permissions, etc. Write allows creating and deleting files. Execute allows entering and getting the properties of a directory or of that file as well. Lines for directories, ls-l output begins with D. We have seen that. It starts with a character D. And then again, these are different set of permissions for different users. Okay. Now we come to a special permission bits, which is setuid, setgid, and the sticky bit 3. So setuid is set on the executable file, and it enables you. So for example, if I have to distribute a file, let's say to you with a executable permission set, and I want you to execute that file irrespective whether I have added you into the others or not. If I set this setuid file, uh, it allow everyone to execute that program as a owner of that file. So irrespective of what permission you set, if this is set, all the users can execute. They may not be able to write anything to the file, but they will be able to execute that file as a file owner. Okay. What it means is any logs, for example, that gets created, or in the memory space, if we see that program, we will see that program as running with that particular owner name. Okay. So we can set this setuid similar to what we have as RWX. Similarly, we have a special permission 421 here as well. So when we say 4, it is a set UID bit that we can set on the executable file. Okay. On a set GID, the executable file calls the program to run with the file owner group. But in this, if you set the set GID, you will have so let's say if you have multiple users and they are sharing a directory, okay, but they are into a different group as well. So let's say you are into a group 1, I am into a group 2, and somebody is into a group 3, but you want that there is a file that you want everybody to participate and contribute to in a one particular directory. So you can set this set GID bit there on that particular directory, and people will be able to contribute to whatever files that you have there. If you set that recursively, people will be able to modify those files as well. Okay, so it's like a common directory where you can put in your public, or if not public, then a common information, and multiple people can access that common information irrespective of whether they are into that group or not. Okay, then comes a sticky bit. Sticky bit is like a it is like a preventive mechanism wherein if I am a user, let's say a user 1 and somebody is a user 2, and if I set a sticky bit on some file which I own, then you as a user 2, if even if you are into a same group that I am in, even if that is the case, you will not be able to change the properties of the file. So which means you will not be able to delete or rename the file that you are not the owner of. So I will only be able as a user, I will be able to change the file only if I am the owner of it. Okay. All right. So you have got access to your system. So what I want you to do is create 3 users on your machine by running a user add command. You simply have to say user add, and I'll say user 1 added, 2 added, and 3 added. Okay. So once you add these 3 users, you have to set the password as well for them. So just set any password for them. Let's say I'm just using the user 1 as user 1 only. Okay. Then for user 2, if I don't set these passwords, these users will be in a disabled state. Okay. So I have got these 3 users updated with the passwords added for them. Now, what I want you to do is create a temporary folder like we have done here in temp. I will use this folder only rather. I am creating a new folder, Reva, Rev, and I will create 3 files here. Okay. Have you added these files and users to your systems?
Yes, I have created 3 users.
Okay, everyone has done that?
Yeah. So how to validate at Ttc password? We can validate it. Right?
Yes. So we can just go to /etc and password file, and we can see that 3 users are created here. So everybody has done that?
Yeah. So umask is applicable only for the file, not for directory.
Yeah, only for the file.
So now the directory have a permission. There is basically 775. And this is coming from somewhere.
So you are asking about the the UMAS for the directory, right?
Yeah.
So UMAS for the directory, if you really look at, so from a file perspective, right? It is like I said, deducted from the 666. That's where you get the mask for the file. Now, from a directory perspective, you can use a umask command to list that as well. So if you run a umask command, you will see that umask as well.
When I type umask, it shows 0002.
Yeah, 0002 is basically, so 0 is no permission, and then 0 is again no permission, and 2 is the right permission, right? So that's a 002. And if you really look at your directory, what it says,
775.
you got it?
Yeah, got it. So it's at the system level.
Yeah,
It's not stored. It's stored anywhere.
yeah.
Can we change this one and say umask?
You
Zero.
cannot change. You can see it. You cannot change it.
Okay.
Okay. You can try doing it, but just set umask and then give another symbol. So for example, umask and then say 055.
Let's say I put umask 001.
Okay. So now if I say umask, it is 001.
Yeah, it is changing.
It is changing, right?
Now if I create a directory now,
Yeah.
yeah, it is changing.
Yeah. I will revert to the default. Okay. So you have said this.
Okay. Do I make 3 files? File 1, file 2, file 3?
Yeah. So I want you to practice on this. Let's say set user ID and the sticky bit, or rather, let's check out the sticky bit itself. Is this noise at my end or everybody's hearing?
No, I can hear you. So I'll sticky bit means chmod
We are
1.
getting the noise.
No, there is
Yeah, even
a
I can
disturbance.
hear that. Yeah.
No, clear for me at least.
And now it's okay.
So, okay. When I say 1, so it is the current logged in user.
Hmm.
It's just Reva.
Hello.
Yeah, so sticky bit is the current logged in user, right?
Yes. Yes.
So it shows some capital T there. So
Hmm.
that means sticky.
No, so small t and capital T both are sticky. If you do not have a write permission, you will see a capital T. If you have a write permission, you will read permission, you will see a small t. If you do not have a read permission, you will see a capital T. From others' perspective.
From others' perspective.
Yeah. So if you have, for example, RWX, and then no permission for others, you will see capital T. Have RWX, whatever RW or RWX, and then R, you will see a small t.
No, can you repeat that? So capital T is no permission, small t is again
You
no
have
permission.
read.
Read.
You have read permission there.
Then it is small t.
Yeah. And you have execute permission as well in others.
Then it will be small t.
Then it will be small t. If you do not have execute permission here, you will have a capital T.
Okay. Okay. So now I have created this particular file. How do I? I'll log out and log in with the other user, or I'll do
Yes.
a.
Yes.
Okay. So I'll basically, how do I do? I'll exit and.
No, just use sudo and then the other file, other username. So you can
Sudo.
say sudo hyphen and then
User
user1 or user2, whatever.
Okay.
So this command, use sudo su user2. This particular command.
I'm not able to switch user like this. Actually, I'm not sure why.
Have you used this command sudo su hyphen user2?
Yeah, I think password. So password is same as the user. It's not.
Anybody else is also having a problem in this?
So when I created the user and giving the password, it was telling that it is less than 8 characters, and it was giving some error, but it created. I saw 3 in the etc password file too, but now I'm trying to log in with this. It is not. Let me use only SU, right? SU user 3. Okay. So if I don't use sudo, then it is working. So if I say only SU, it is working. Okay. So I cannot even get into the files which I created. Reva in temp folder I created Reva. I don't see that it user 3. Okay. Okay, no. Okay, I think I'm not bad 6. Okay. So when I try to cat this with user 3, it is giving me permission denied.
Correct.
I think so. I'm not sure. Okay, because it is created with Reva, and then I am using user 3.
So you will not be able to delete or modify or rename anything onto that.
Yeah, I cannot read it. A modification also not happening. I cannot even cat it. Okay. 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 So I created a folder, user 3 folder with user 3, and I'm able to get into that folder using Reva. But from user 3, I was not able to get into the Reva's folder.
You probably would not have a read permission on the directory or the execute permission on the directory. So on a directory, until or unless you have an execute permission, you will not be entered into the directory.
Okay, so but what I did was okay. But from Reva, I'm able to cat this. So maybe it is part of the same group, or I'm not sure what really happened.
Can you share the screen?
When I tried to, I did this.
So go to the user folder 3.
Yeah. So when I so this was all created by Reva. So when I tried to cat it, it didn't allow me to even cat.
No, so create a new folder.
In Reva?
Anywhere.
Okay. Okay. So this was created by Reva. So if I say,
so who is the owner? Just show me the permission for this folder first. Batch 6.
okay. Oops. Sorry. Okay. So it is having Reva is the owner. Group is Reva.
Okay. And they have a read and
Directory,
execute
and it is.
permission.
Yeah. So this is. Now, if I say, sorry. So here I created some file. Okay, so okay, then I say 1. I'll give some less permission. Let's say 7. Maybe 1. Sorry, 2 times. So I'm giving the user only user 3 permission for this. Okay, so I have full permission, but others don't have. But I didn't give read option, but still, but here, okay, if it is not having anything.
Yeah, so if you do not have a read execute permission there, you will see a small t. Here you have given a R permission and probably a executable permission as well. Or you have not given the executable. No, so you have not given the executable, right? The user leave, user file aging. Yeah, so this file that you created, user 3 file, whatever the name is, it doesn't have an executable permission. So you see a small t here. If you have an executable permission, it kind of combines with a sticky bait. So it kind of gives you a capital T permission there.
Okay. So this one has no meaning in sticky because this is, I think it's read and write only, right? The third value, which is the one value.
No, so even the user 3 file, for example, so if you see user 3 file, the other group people will be able to read and execute this particular file without any issues. Okay.
Read.
Yes.
Okay. But it should not be able to write it. So if I exit from here.
Correct.
Okay, I'm in Reva now. So I think. Sorry.
So if you try to rename that file.
Okay. Now I have. So if you see here.
Yeah. So try to rename the file. Let's say user3 file.txt.
So rename is move, right?
MV command, yeah.
Okay. So if I say user3 file to okay, permission denied. But if I see now I have okay. So other thing is in the first one user3 file again txt. I should not be even able to cat it.
Yeah, because you don't have a read permission as well there.
Yeah.
Okay.
Okay.
So I'm in a user2. So I do not have a file. So let's create a file. I have created a file. Now, what I want to do is I want to make this file immutable, which means I don't want anybody, including the root user, to delete this file. Okay, so what I can do is I can say chattr plus small I on this file with a super user. And I entered my, I enter my password. I'm a normal user. I go to my home. Let's see. Let's say I create folder Reva. Here I created a file and I say chattr plus I on this file. Now, if I see the file permission looks pretty normal, I mean, there is no issue with the file permissions, and I am the owner of this file. So I am the owner of this file, and my group is also the U1, and this is the file. Now, let me try to remove this file. I get operation not permitted. It is not about permission denied, it is about operation not permitted. Let me try with the sudo command as well. So even with the super user, I am getting the same error of operation not permitted. Why? Because I have set a immunization bit on this file. How do I see this? Via LSATTR. So list the attributes. Now, if I list the attributes of this file, I see a small I listed down there, right? Which means that this particular file is now having an immunity from a deletion perspective, and I will should not be able to rename it either. So let me try this. I will not be able to rename that either because it is
If we
immune.
go for a force removal RM-RF, then also will
I
not.
Yes. So let's try that as well with sudo as well.
Okay.
Okay. So this is a immunization or whatever we want to call it. It provides an immunity from a deletion or from a hard link or from a soft link perspective. I will not be able to do uh, any removal or any modification to this file. Now, if I go to etc and I look at the attributes, so let me do that with the sudo. I don't see those attributes set out here or any of the file. So what we can do is we can set this immunity bit on our password and the group file so that nobody will be able to delete this file from our system. So what we can do is we can do chattr with sudo plus I etc password. That we can do etc shadow and we can do etc group as well. Now, if I run this, I see my etc group is immunized. Same goes with the password. Same goes with the shadow as well. Now, this is about the immunity. Now, what all other things that I want to do with this? For example, I don't want my access time of a file to be updated. Even if I access it, read it, write it, I don't want my access time of a file to be changed. What I can do is I can do chattr plus capital A and then on the file that I want. Now, if I do lsattr, I see that capital A bit is also, or the attribute is also set. Similarly, I can set with a small c. So small c, for example, let me just open up a notepad. So capital A will not modify the A time of the file. I is providing immunity to the file from rename, deletion, then small c is to provide the compression immediately when saving the content on the file. So if I have this C attribute set, it will automatically compress the file on the disk by the kernel. Similarly, I have a small d, wherein if this is set, then during my dump program, so with the dump, I will not be able to take a dump of this. So dump program will not include this into a dump. So this D will basically tell me that if I have a capital F as a flag, for example, then this capital F attribute, it indicates that all the lookup of the path in the directory, if I run a find command or if I run a grep command inside the directory, they will be case insensitive. So all lookup into a path in this directory will be case insensitive. So that's a capital F that that tells me that, right? So similarly, when we are doing an audit of any system, and specifically if that's a Unix system, we should run the lsattr command to verify whether these kind of attributes are set or not. If these are set, then we can question the administrators that why these attributes are set. And if it is not, then it is normal. If you really look at um, uh, the audit checklist that we have on the CIS benchmarks, for example, they have also called out this particular audit to be run specifically and explicitly.
How this is a security risk?
How this is a security risk? If there is a malware which is with the plus I, and your antivirus is not able to delete it because even the super user cannot delete it, then your malware essentially lives on the disk forever.
Okay, yeah. The other thing is when we are taking a dump is basically taken from the memory, right? So this is a storage. So storage also comes in a dump?
Crash dump, when you take the content of the memory and the disk, both comes.
Okay. Okay, yeah.
Yeah. So from security standpoint, that's where we should be aware about the CHATTR or LSATTR, for example. Like CHATTR, we have given the permission with plus, we can also revoke the permission with minus. So in this similar case, for example, if I have to remove the permission of I from password file, I can do that. And when I do lsattr on password, my I is gone. Right? So that's on the CHATTR. Okay, and we are back here. So this is about changing the permissions of using the chmod, and we have already discussed about the -r. We can also change the ownership of the file. So if I go here, for example, let's go to a temp folder. And if I have to change the ownership of this rev folder to, let's say, user one, I will be able to do that with the ch own command. Again, I have to run that with the super user. So ch own command. Recursively, I want to do the ownership change. So user one, and I can put dot user one and the rev. Now, why to user one? This one is for the group. This one is for the group, and this one is for the, oh, sorry, this one is for the user, and this one is for the group. So user one user and user one group. So sudo ch own change the ownership recursively for user one and user one group on this particular folder. So if I now look at the outcome, here it was u1, here it is user one. And if I look into the ref folder itself, it will be user one again, because recursively we have changed the user and the ownership information on the file. Clear?
So it is inheriting from the directory. Right?
Yes.
Sorry?
It is inheriting from the directory. Right?
Yes. So it is not inheriting, it is recursively setting.
Okay.
So iteratively, it will go into the directory, whatever directories or files are there, it will change for that as well. If you don't give this -r, then it will change only for the directory and not for the underlying files or the folders there.
Right. One question related to the attributes which you explained on I and A, B, all those
Correct.
attributes. Related to the security aspect of things, when we harden the computers and when we harden the operating system, do you see these attributes are used for sensitive locations or sensitive directories where we want to enforce certain ACLs? Example, one such example which you mentioned was the password D, which definitely we need to want. We don't want someone to modify that, or we don't want to lose the data. So in such cases, do you see the hardening rules recommends such kind of attributes to be set?
So you tell me, what are the different files we have seen since the morning? So etc password is one of them.
Yeah,
That's what we have seen.
that is one.
That is one. What else? Etc Fs tab we have seen.
Yeah,
That is the second one. We have looked at the /lib and then system, then whatever the path is, and then the *.run level.
yeah,
Yeah. So what is the purpose of password? The purpose of it is to store the user information. It's a user database. Fs tab is, I do not want anybody to change anything in Fs tab, because anyone can then be able to mount, for example, a USB drive or a CD-ROM drive or a remote share onto my environment. And then the exfiltration will become easy, or the infiltration will become easy.
right.
So I don't want Fs tab to be changed, for example. I don't want run levels to be changed, the configuration of run levels not to be changed, so that nobody will be able to use a run level 4, for example, or alter a run level 5 to execute a particular service which is not approved by the system,
Correct.
right? So which essentially means that any system file that we have, any file which is stagnant, once we have changed it, we know we are not going to change it anymore. Any kind of that file we need to immunitize as well. So for example, Fs tab, we have, let's say, configured the Fs tab we want it to be. Then we can set the +i onto it so that it doesn't get deleted even if the system crashes, for example. We don't want that to happen, and then we lock down this file by restricting the permissions as well,
Yeah,
right? Similarly, on this run level files, we do not want these run level files to be corrupted, and we do not want anybody to delete these run level files and replace with their own files. So we will immunize those files as well.
If I use -I across these critical files, I won't be able to edit also, right? Or
You will be able to edit, you will not be able to delete it.
delete it, yeah. Only deletion,
Yeah.
okay.
Yeah. So renaming will not be allowed, deletion will not be allowed. Then if you have a soft link where you immunize, you will not be able to change the soft link itself. So soft link will always point to one particular file itself.
Okay.
I have one silly question. Actually, the
Question is clear.
example you have given that plus I there is a malware that created a file and antivirus was not able to delete it.
Hmm.
Okay, but we have the authority to edit that file. So I mean, so the antivirus has any kind of intelligence. If they are not able to delete it, they will empty that file by echo. I mean, they delete the content of the file.
They can, given they have a permission to do that.
Okay. I mean, they do it. I mean, you have seen it. I just want to
No,
know.
so the example that I gave of a malware,
Yeah.
see, typically what antivirus performs, antivirus will try to first of all delete it.
Yeah.
If they are not able to delete it, they will try to move it to a
Okay.
quarantine folder.
Okay.
In this case, if they are not able to move it as well,
Okay.
they will simply they will put up a warning or an error message that they have not been able to successfully work on this particular file,
Okay. Okay.
right? But they will not empty the content of it.
Okay. Okay. Got it.
Okay.
Yeah.
All right. So what we will do now is, let's go back here. So changing permission we have seen. Let's wrap up this. Okay. So extended ACLs. Now, the stuff that we have seen right now is all about uh, it's all about the basic ACL, where we have RWX, we have sticky bits, we have SGIDs, SUIDs, etc. Now we will work with the extended ACLs. Now, extended ACLs, you can think of it like ACL in Windows itself. So, for example, let me go to uh, Reva folder. So here, if I see, what I can do is I can do a get Fsel command, and then with the rev folder on top of it. So what I see is I see a user RWX, group RWX, and then other RWX. This is the normal stuff that we have, right? This is something that we discussed in the morning as well, that these are the get FACL stuff. Now, what we can do is we can get the display of the FSEL or the extended ACL on a folder, on a file, and it'll show me like this, which is a group user, other, whatever we want to call it. Now, sometime the ACLs are very, very large. So this list kind of scrolls down. So what we can do, we can just ask them to show us in a tabular way as well, so that it becomes easier for us to read what permissions it has. So we can do that as a table dump of the permission. Okay. If we want a recursive permissions to be done, we can do a -r to it. and it will show us a recursive permission. So recursive means a ref folder, then folder in a file, folder in a file, folder in a file. So it gives me a recursive display of the permission. Sometimes we have a symbolic links, which is like a shortcut. If we want those shortcuts to be walked upon, so walking means if you want the command to follow that file which is getting linked, we can use -l, or if we do not want those files to be walked upon, we can give -p as the uh, parameter. Now, suppose we want a number display to be given, so we can look at the number display as well. Now, these number displays are nothing but the user IDs of the number. So, user, this is a UID group, this is a UID, and so on. So, we get, rather than the user one, we get their user IDs in a number format as well. Okay, this is clear.
Yeah.
Okay. Now, let's say we want to set the command. So what we can do to set the command, like we have a get fsel. Similarly, we have a set fsel command as well. So let's go to a rep folder. Here we have 3. So let's take a fsel of one of the file1.file. So this is what it is. So let's set fsel. So set fsel -m is to modify the permission. I want to add a user2, so user:user2, and I want a read write x. Here, if I see other is getting a r minus minus, so they will not be able to uh, change anything in this file. But I want a user2 specifically to do a read write and execute on this file with the sudo. Okay. So now if I run this command again, get fsel, I see that a user2 is getting a rwx permission, right? And if I see that in a tabular format, which is much better looking like, so I see a user. So there are 2 users of this file. So user1 and user2. User1 is only read and write. User2 can read, write, and execute all the 3. On a group level, user1, anybody in the part of a group of user1, they will be only read and write, and mask is RWX and other is nothing. Now, I am a user, I am a U1, not even a user1. Okay, so I am a U1, and let me try to edit this file, which is a file1.file. And you notice this plus here, it basically denotes that there is an extended ACL on this particular file. Now, let me try to edit this file. First of all, it shows me here it's a read only, but still, let me try it. Trying it out and then save. It says it is a read only, so I cannot do anything. Even if I put an exclamation, it doesn't allow me, so I quit. Okay, I can read this file though, so it's still empty because I was not able to add anything to it. Who can add? Only user1 and user2. So let me put some. So let me become a root first. And let me put up a message. Hello world. Okay, since I am a root, I will be able to do it. So once I execute this file, I get this message, which is the expected behavior of a root. Now, let me switch myself to user 1. I'm a user 1. Let me go to TMP folder. Let me go to ref folder and user 1, owner, user 1 group, file1.file. Can I edit this file? Let's see. Should be able to. Now, can I execute this file? No, permission denied. Why? Because I do not have a X here for a user 1. Now, let me switch to user. What was that user? 2. User 2. So let me switch to user 2 and go to a temp folder, rev directory. And now I will be able to edit this file as well. And I will be able to run this file as well, right? Whereas I am not the official owner of this file, but because I have been given a execute on this file, I was able to execute the content of this file. Clear?
So it's very difficult if we are auditing, because here we'll show user 1 and nobody will even know that user 2 can have this kind of permission unless.
Correct. That is where you have to look out for symbols like this, or rely on the command of, the what do I say? The lsattr. So those commands comes in handy.
Okay.
So
Yeah.
when you get the when you run the command get fsel recursively, you get the dump of the file permissions, right? And that's where you will have to look at those permissions at a granular level, whether there is anything of that sort or not.
Yeah, correct.
Yeah.
Yes, yes.
So simple. I think it is simple itself, right? Now you can set the permissions recursively as well, like we have seen it for a get fsel. So like we have seen it for the get fsel, to get it recursively. Similarly, like we are getting this, we can set the permissions as well recursively by using the -r. Again, capital R, similar to what we have done with get fsel. Same thing we can do with the set fsel as well. So if I go here and if I say sudo set fsel user 2, let's say user 3, and I want RW to be done, and I want this to be recursively done on the ref folder. Oh, -m on a ref folder, then I will be able to look at, for example, get fsel rev. So I see user 3 added here. If I recursively do -r-t and -t, I see that on a file 1, I have got user 1, user 2, and user 3, and user 3 on all the places here. Okay.
Yes.